Welcome everyone, and welcome to the AluVET Vocational Training and Education for the Aluminium sector. This training is co-funded by the Erasmus programme of the European Union. I am Jan Lukaszewski, the Technical Manager of the Aluminium Federation in the United Kingdom. The Introduction to Metals series of modules explains the simple theory of metals and of metallurgy to enable students in subsequent modules to understand aluminium, its alloys, heat treatment, and how it is rolled, extruded, and or welded. This project is funded with the support of the European Union. The publication reflects only the views of myself and the Aluminium Federation, and the Commission cannot be held responsible for the use which may be made of the information contained therein. This module, Aluminium Temperature Measurements, we will teach you how to accurately measure the temperature of aluminium, particularly at elevated hot working temperatures. So extrusion, welding, rolling. You will learn about the different methods of measuring the elevated temperature of aluminium and about the problems of measuring the elevated temperature of aluminium. You will learn how to identify errors and how to minimize or eliminate the errors measuring the elevated temperature of aluminium. You will learn how to correctly measure the temperature of aluminium at elevated temperatures experienced during such processes as heat treatment, extrusion, hot rolling, and or welding. The problems of measuring the temperature of aluminium are that aluminium has a low melting point, 660 degrees C. Some of the silicon alloys melt as low as 540 degrees C. 500, 550, 600 are just perceptible red heat in a dark room, which means that aluminium elevated temperatures cannot be measured using a disappearing filament pyrometer. Aluminium, even at elevated temperature, has a highly reflective surface. It's silver, it appears silver, very, very reflective. Aluminium has high thermal conductivity, so its surface is prone to surface chilling. Aluminium in contact with air, oxygen, forms an oxide, alumina, which is a ceramic, a thermal insulator. Alumina has totally different thermal characteristics to those of the underlying parent aluminium metal. And heat treatment, particularly aerospace heat treatment and hot working, requires very, very tight, narrow bands of temperature control. So let's look at one method, the infrared pyrometer. An infrared pyrometer measures the temperature at a spot on the surface. The infrared pyrometer detects the electromagnetic radiation in the infrared part of the electromagnetic spectrum, and based on that, it can measure temperature. The infrared pyrometer consists of a lens that focuses the infrared thermal radiation proportionate to the object temperature onto a detector, which converts the detected radiation to an electrical signal that can be displayed in units of temperature after a simple mathematical transformation. The biggest advantage of infrared pyrometry compared to conventional temperature measurements such as thermocouples is that it permits temperature measurement of a surface from a distance contactless. So you can measure welds at a distance away. You can measure what's going on in a hot rolling mill without needing to touch the sheet or use thermocouples. Now, emissivity is a measure of how effectively a surface emits infrared energy. Infrared pyrometers measure infrared energy, emissivity. And emissivity is the opposite of reflectivity. Aluminium is highly reflective, and high emissivity makes a surface easy to measure using an infrared pyrometer. However, aluminium has low emissivity, much lower than that of carbon steels and stainless steels, so it is difficult to measure its temperature through infrared pyrometry. For accurate results using an infrared pyrometer, the emissivity must be corrected for the surface being measured. Now, infrared pyrometers have an emissivity correction knob on the side of them where you set the emissivity.